Let's jump right into Puleng's question and see what the question was all about and how do you really work your way around this. Right. So this is a nice question that is based on 2D and 3D trigonometry, and it reads as follows. A, B, and C are 3 points on the circumference of a semicircle in a horizontal plane. Right. And then we are told that AC is the diameter of the semicircle that the examiner is talking about. EC is a slanted pole in the vertical plane through C, forming an angle of theta with the vertical. The angle of elevation of E at A is beta. BC is equal to X. If you go further a little bit lower, you'll see there's point B right there at the bottom, and the length of BC is apparently X, and angle ACB is also equal to alpha degrees. Right. Now, when you're dealing with 2D and 3D questions that are basically revolving around trigonometric basics that you've covered, right, you need to understand a few things about what is happening now. In grade 11, you were only dealing with 2D, which means you were dealing with questions that are flat on the surface, right? But now you're dealing with 3D because you are in grade 12. You will notice that now we are no longer looking at the horizontal plane, but you're also looking at the vertical plane. So whatever you're going to be looking at, you need to keep that in mind. You need to try and create a picture in your mind that will help you to see what is lying on the horizontal plane and what is lying on the vertical plane, because the angles that are lying on the horizontal plane can't be interacted with those ones that are lying on the vertical plane. Right. Okay, cool. So let's see what is going on in this particular question. So some of the terminology that I want you to pay attention to that are very critical before we start even dealing with this question are words such as the story of line, angle of elevation, and angle of depression. If I may create a small picture to help you, imagine if somebody was standing on top of a building like this, and this could probably be any building anywhere, right? And we've got one person who is right there at the top. And if this person is looking down to somebody else who is also standing somewhere here, right? Let's just say maybe there's Chantel here who's standing there. According to person A, who is on top of this building, the angle that they are looking through here is known as the angle of depression. This angle here, which I might call theta, is what we call the angle of depression, right? The angle that you see, the bird's eyes angle. If you're standing there at the top and you're looking down, your angle versus the line here that I can call the line of reference is what we call the angle of depression. But for the girl who is right there at the bottom, her angle with respect to the horizontal, which I might call alpha, I might call it anything that I want. This one will be known as the angle of elevation. So when people talk about the angle of elevation, they're speaking about the angle that you are actually creating with the horizontal when you're looking up. But the angle of depression, even the words tell you that depression is about going down. It's about decreasing. You hear what I'm saying? So please keep that in mind when you're working on these questions. All right, cool. So if you look here, we are going to start seeing what the question is all about as far as what is going on is concerned. So the first question says we need to show that AC is equal to 2 divided by the cos of theta. Okay, Puling. So I want to show that AC is equal to 2 divided by the cos of theta. So I'm going to go to my diagram and try to locate where is this AC that they're talking about. So if you go there and you check AC, you'll find that AC is the diameter that they told us about. It is this length here, this one here, that the one that they actually looking for, right? Now, it is actually assigned in triangle ABC, so which means I can focus on either triangle ABC or triangle AEC in an attempt to work out the length of that value of AC. Now, the problem here is you never really know which triangle to begin with until I tell you the following. The best triangle to use is a triangle that has got a minimum of 3 things. So if you look at triangle ABC, so far we've got 2 things. We've got the angle of alpha there, and we also know that the length of BC is equal to X there. So, but if you look closely, we know that an angle that is subtended by diameter, that angle that is subtended by diameter AC here, has to be 90 degrees, and this comes from our geometry, the knowledge of Euclidean geometry that says an angle subtended by diameter has to be 90 degrees. So in my argument, I'm going to begin by firstly arguing that particular part. So I'm going to say to the examiner, angle B has to be 90 degrees because I can't use any of my trig if I don't have a minimum of 3 things in that diagram. So angle B is equal to 90 degrees, and the angle is because, the reason is because this is an angle that is subtended, right? by a diameter. An angle that is subtended by a diameter will always be 90 degrees. Now, once I have this, I can then start applying either the sine rule or the cosine rule, or I can even use SOHCAHTOA because this is actually a right-angled triangle. So if you look closely, you will notice that angle C is actually adjacent to the side X, and we know that AC is basically the hypotenuse to that triangle that is lying on that horizontal plane. So I'm going to use the ratio that relates the adjacent side with the hypotenuse. And if you remember, according to SOHCAHTOA, that has to be the cosine, the part of cosine. So I'm going to say to the examiner, the cosine of alpha can be given by the adjacent side, which is x, divided by the hypotenuse, which is basically AC. And if you look there, you will notice that indeed the side x is adjacent to that angle alpha, and your AC is the hypotenuse to this particular triangle. So what I'm simply going to do is I'm going to try and simplify what I'm looking at, and you will see that if we try to cross multiply here, you're going to get that if this is over 1, right, you're going to get that AC multiplied by the cosine of alpha is equal to that x that you're looking at there. And then if you continue here, you will see that the answer to what you're looking for is that AC is simply going to be x divided by the cosine of alpha. Very important for us to keep that in mind. Now, if you go back to the story that we were given here, you will see that indeed we did find the value of this because the length of AC is the one that you're looking for, and your BC is actually equal to x. Right, moving on to the next part of the question. We're now required to determine the expression for AEC in terms of theta and beta. Now, AEC, if you remember on the diagram, we've got the part that actually looks like that, right? And this part here was given to us as theta. We know that this is theta. The top angle here is E, and then if you look closely, you will remember that we do have A and C, which is the diameter that you're looking at there. So that's A here, and this one is actually C. So we are looking for this angle in terms of theta and beta, because here we know for a fact that we were told that this angle is equal to beta. So when I simplify this, I'm going to simply say, okay, fine. According to what we are sitting with here, we can be able to find angle C1. I'll name this one angle C1. Angle C1 plus theta must give us 90 degrees. And therefore, we can conclude that angle C1 is simply 90 degrees minus theta. Right. Now, once I'm done with that, I'm now going to try and find the value of the angle that the examiner is asking us to find, which is that angle at the top, angle AEC. So if I add angles of a triangle, the angle they're asking me about, angle AEC, plus the angle at the bottom, which is beta, plus angle C1, which is 90 degrees, minus theta must give us 180 degrees, because these are angles of a triangle. The sum of interior angles of a triangle add up to 180 degrees. Right, and then we can simplify this. You're going to get that AEC, right, plus your beta there, plus 90 degrees minus theta is 180 degrees. And then if I take these ones and I subtract them on both sides of the equation, then the angle that I'm looking for, which is AEC, will just simply be 180 degrees minus beta minus 90 degrees plus theta. And if you clean that up, you will notice that 180 does indeed help us to subtract 90, and the final answer comes out as 90 degrees minus beta plus theta. That will be the value of that small angle that is lying right there at the top, which is angle AEC. The last part of this question that Puleng sent to us is asking us to show that the length of EC is equal to x sine beta divided by the cosine of alpha multiplied by the cosine of beta minus theta. Now, once you start getting questions like these that are asking you to prove something, right? Don't panic, because what you have to prove sometimes looks very complicated. What you need to do is just think about it and say, okay, I am just asked to work out the length of EC in this case. So I'm going to go to the diagram and try to check what is this EC that these people are asking me about. All right. So let's go back and see what the story is going to be there. They're asking you to find the length of EC. EC is this distance that you guys are looking at right there. That's the length that we are looking for. And it is a length of triangle AEC. So I'm going to reproduce that triangle. I'm looking for the length of EC, and I'm going to keep writing everything else that we have found up to so far as we're trying to simplify this question. So let's go further and see what will happen if we do that. So allow me to reconstruct that triangle that will be given. That is actually this question that this question is based on. There's a triangle there that looks like this. We just found that this angle is simply 90 degrees minus beta minus theta. We know that this angle here is beta. We know that this is C. We know that here we've got A, and we know that this is this one is going to be B. Is that B? Let's compare and make sure that we're not copying things wrong. It's C on the right and A on the left. So A on the left and C on the right. Okay, let's see what will happen. So C is simply the angle that you're sitting with there, right? What is the value of the angle at the top? The one that is right there at the top is angle E. That is angle E, right? So that is going to be angle E. Now, we have found already a couple of things here, and we are asked to work out this one that you are currently sitting with right there. So I'm simply going to say, let's see what will happen. This one is angle C. Make sure that everything is working well. Okay, cool. We're happy with that. So now I'm going to construct, I'm going to develop this solution by using the sine rule. The sine rule says the length of EC, right, divided by the sine of the angle opposite to that side is given by the length of AC divided by the sine of the angle that is opposite to that, which is 90 degrees minus your beta minus theta. This is simply what you're sitting with, yeah. All right, now if you proceed here and make EC the subject, is going to simply say EC is AC multiplied by the sine of beta. So what I'm simply doing, I'm just cross multiplying this beta, that side, in order to make EC, which is what they're looking for, the subject of the formula. And then if you divide, you will notice that on the denominator, I've got the sine of 90 degrees minus beta minus theta. But according to reduction formulas, you will know that this part here can be simplified using the fact that the sine of 90 degrees minus anything can be reduced to the cosine of that particular angle. And that's the result that I'm going to use in this case. So my sine will now change and become the cosine of that angle you see there, which is beta, right, minus your theta there. Right, and then if you go back to what we have found since we started simplifying here, that AC that you are looking at here, this AC was one of the things we asked you to work out in the beginning, and we found it to be x over the cosine, right, of alpha. So I can substitute this there where I see AC, x over the cosine of alpha multiplied by the sine of beta, and everything should be divided by the cosine of beta minus theta. And if you simplify this, then you will then get that the answer is x sine of beta divided by the cosine of alpha minus multiplied by the cosine of beta minus theta. And this will be the solution to this question. I hope you saw what you needed to do there. The only thing you must keep in mind all the time when you're working with these questions is make sure you identify a triangle that is a minimum of 3 things. And then you either apply the sine rule or the cosine rule. You've got to know the conditions that you need to engage in order to apply either the sine rule or the cosine rule.